Hello, everybody. Welcome to Saturday Hacker Day. My name is Taggart. You can follow me most places right there at MTTaggart. And on this channel, we're doing cybersecurity, we're doing programming, and sometimes we do some CTF competitions to build our skills. Today, though, we are doing some pretty exciting stuff. We're going to do a deep dive into a specific skill set that is crucial for our line of work, but often gets overlooked as kind of an add-on. But if you master it, you're basically a superhero inside of all of IT, but certainly in cybersecurity. But before we get to that, we have some work to do reviewing the week's news. This week in cyber, two stories worth a quick mention. Let's start with VMware. VMware released a really ugly vulnerability in the last week. Actually, they released two. And let me just get to the story here. There we go. So CVEs 2021 21972 is the really nasty one, and then an ancillary one 2021 21973 are remote code execution vulnerabilities on VMware products, ESXi, and, well, basically the vCenter server software, so anything that runs that. So that would be vSphere as well as ESXi hosts. Really, really nasty. It is being compared a little bit to the Citrix ADC vulnerability 2 years ago, which was 2019 19781. And it looks to be there are two parts of this vulnerability. The first is an endpoint, a URL on the server that allows arbitrary code execution unauthenticated. That's one. Two, the second vulnerability has the possibility for server-side request forgery. So that's kind of interesting. What you can do is then submit a request to the server and have it make requests on your behalf within its environment. So you can kind of almost end up using it as like a reverse proxy and get do some reconnaissance within a network if the virtualization host is sort of a bastion host between, the inside and outside of a network. So it was assigned a CVSS score of 9.8, pretty ugly. If you're running VMware, make sure your stuff is patched. And we are definitely already seeing proofs of concept for this vulnerability. So yeah, definitely get on that. Up next, we have really interesting news in the Mac malware world. This piece of malware is being called Silver Sparrow. It's not entirely clear yet what it does, but what is interesting about it is that it has been cross-compiled for both x86 processors and M1 Apple Silicon processors. So this malware, whatever it does, and it may just be a proof of concept at this point, researchers can't really see that it's doing anything particularly evil. It's one of the first, if not the first, piece of Mac malware we've seen that is specifically targeted to new M1 chips in the new Apple computers. So it takes advantage of the JavaScript API in the package installer, which I didn't even know there was a JavaScript API for that. But really, really interesting. We don't know what it does yet, but it's clear that attackers are actually moving ahead of some companies to cross-compile for M1. And it's not exactly difficult to build specifically for an ARM chipset, but you have to take the initiative, make the effort to do it. And it's clear that even though Apple market share is still, far below what Windows is, it's a high value enough target. And I think, I don't know if this audience really needs us to dispel the idea that, Macs are safe or whatever, but they're not, right? There's definitely malware and certainly adware and spyware that is around for the Mac OS environment. And the other thing is, when you think about your target, right? If I'm targeting somebody to exploit or spy on or, send adware, whatever it is, there are a couple of things about Mac users that make them really appealing. One, they're really affluent, kind of just as a default. I mean, that's not always true, but the barrier to entry to buying an Apple computer is higher in many cases than acquiring a Windows computer. So you're tending to get, from a socioeconomic standpoint, a higher starting point. Which means there may be more to exploit there, right? There may be more willingness to pay for things. That's one. Two is, depending on the user that you get, often people will get Apple computers because they want their device to just work. And I'm not saying that Apple users aren't technical. Certainly the developers that use them are technical. Nevertheless, your population may be more likely to put up with spending money for something one way or another. And again, because of that socioeconomic status, it's entirely possible that an Apple target will net better results if you're looking at a financially motivated attacker. Hey, Alyssa, what's going on? So that brings us kind of to the end of our cyber news. And we're ready to get started with what our main event today. By popular demand, we are going to do a deep dive onto a specific skill set in the cybersecurity universe, which is regular expressions, or regexes. I love me some regular expressions. I use them literally every day. And it's something that everybody is familiar with, but I think most people who work with regular expressions kind of like hold them at arm's length, right? They'll know a couple of things on how to deal with them, but they really won't feel confident looking at a regular expression and being able to parse it. Very much the way that I feel looking at, like, I don't know, the Einstein field equation or something like that. It's a language that just is so alien that your brain shuts down and you don't process it. So we're going to stop that today. We're going to do a deep dive into regular expressions, how they work, and how to use them to really kick your cyber game into high gear. So let's get started. Now we're going to focus on, get over to my live scene here. We're going to focus on regular expressions as a tool independent of the piece of software that you're going to use them in. That said, you've been on this channel before, you probably know that I'm definitely going to be using Vim as my text editor, but everything that we do can be done in other text editors. And my second recommendation for a text editor, if you're not going to use Vim, and there are a lot of good reasons not to, I totally understand it, is Visual Studio Code. It is, it is rock solid, it's cross-platform, and it does have really strong support for regular expressions. So if you need to download that, you can grab that at code.visualstudio.com. And go ahead and grab it for Windows, Mac, or Linux, whatever you're on. All right, so we're going to start talking about regular expressions in general and what their intent is and what you can do with them. Everybody knows about Control F, right? How you can search text, whatever it is, for whatever you want to find. But that Control F is very limited because you're just dealing with words, numbers, just kind of in a straight pattern. There's not a lot of dynamic pattern matching going on there. And that's exactly what regular expressions are intended for. So I'm on this site here, regexer.com. It's a really nice kind of practice platform for getting to know how regular expressions work. Here in the main body, I have kind of this test text, and I can put any test text in here I want. This is kind of the default. If I really wanted to, I could go, actually, I'm going to do it because everyone should know about this. Jeffsum.com is one of my favorite places to get filler text. So yeah, let's get like 8 paragraphs of Jeff Goldblum quotes, right? And we'll copy this in and go over to regexer and fill that in here. Now, there are a few things that this doesn't have, right? Like domain names and things like that, and we'll put those in here as well. But for now, we have a pretty good starting point for practicing with our regular expressions. So up here, we have our regular expression, and it's between 2 forward slashes. That is a syntax that you're going to see pretty often. You're going to see it if you use Vim, and you're also going to see it if you use the sed command line tool, which is itself actually a programming language. But with sed, it's for stream editing. So with sed, if I do something like let's echo password, right? And then I'm going to send it using the pipe command to sed Did you know that rand equals 5 in Word gives you 5 random power graphs? I just learned that on Twitter the other day. Blew my mind. I don't actually have Word installed on this machine, but yeah, that is pretty cool. Yeah, we may have seen the same tweet. So with sed, right? If I wanted to substitute the O with a 0, I would send it to this command, and I do s/o/0, and what that would do. Oh, hold on a second. Another forward slash. Yeah, there we go. So you can see that / syntax where I'm trying to match on this pattern here, and then I want to replace it with this here. Now, interestingly, if I had, while we're here, if I did that twice, notice that it only replaced the first one. So something you'll also see at the end of the / is the expectation of flags. And over here, you can see after our flags, we actually have a G. And that flag is for the global case, meaning that it's going to make that substitution, if it's a substitution, or the pattern match, if it's a pattern match, across the board, okay? Or you could do it by multi-line or just single line, but global is often what we're doing because we want to match on all. So if I add a G to the end of this as my global flag, both of those O's, you'll see, it will be replaced with zeros. So I just wanted to start there, that if you're going to be using regular expressions, you're going to often see this / syntax for substitutions or for matching. And I don't want you to get thrown by those /, especially because as our regular expressions get a little bit more complex, it's going to get a little bit harder to read because we have to use a lot of backslashes and / to get what we want. And just understanding piece by piece what those mean, going to be handy. Okay, so those are what those / are about. Now inside of the / here, we're going to put the pattern that we want to match. So for example, let's say that I wanted to match every exclamation point. Real simple, right? A single character will do the job, right? Very simple. And I could have done that with Control F too, right? That's not actually interesting or new. Let's get some music going. I'm gonna keep it chill today because there's a lot of information coming at us. Yeah, there we go. All right, so we have a single character pattern match. Let's do a little bit better than that. Let's try every word with a comma after it. Okay, so if I just do a comma, you'll see that I get the comma, but I want a word before it. So to do that, I can do, let's say, if I just do like a letter, right, I'll get anything with an A. How do I do groups? There are lots of ways in our regular expression syntax that we can use to match groups of characters or classes of characters. So you can see here in our regex reference, this is a little small, let me zoom that in. If we click on character classes, you can see that I have character sets. And there are also certain special symbols for things like words and not words. So if I do /W, \W, I should say, \W matches any word character, right? Any text character that isn't a digit before. So for example, if I were to put like a 1 here, oh, it does match. So sorry, 1 is /W is all alphanumerics. That's right. But if I do /D, that's only digits. Yeah, that doesn't work. But if I put a 1 here, that matches. So if I have here just /W, that'll match all alphanumerics, which may not be specific enough for my purposes, but for now it is. Now, I'm only matching one of them, right? But I want the whole thing. So in order for me to match more than one, I have to use quantifiers. So a plus quantifier will say 1 or more. And a star is any 0 or more. But I do want 1 or more, so I'm going to say \W and then a plus. And that matches every word that precedes a comma. Now, let's say I had, for whatever reason, like a bunch of different, like I had like those, and I didn't want those matched. How could I just get letters and avoid this pattern here? With other kinds of character classes, I could do that a little bit. So notice that in the square brackets, I can do backslash, or not backslash, I can do square brackets and put in AZ, and those I can do both capital and lowercase. So if I do AZ and then A-Z, this matches all uppercase and lowercase letters, or I should say the 26 character alphabet. That's what it matches there. And notice that I'm getting everything I was getting before, but I'm not getting those numbers that I put commas around. This isn't the chill beats that I wanted. I hate to be too about the music, but it really matters to me. There we go. All right. Get a little like Bob Ross vibe going on here. Not that I'm comparing myself to Bob Ross. All right. So we have these character classes, and these are incredibly useful for us. Now, we can also create our own custom character classes. So if I just wanted to match like a certain set of letters, I could say like IOU, and that matches just, actually let's do like the whole vowel set, right? That just matches any vowels that prepend. And again, I'm doing that because of the square brackets. Now, let's say that I wanted to match not E's. So no, not E's. I can actually use the negated set here to match everything else except E's before commas, for whatever reason. Okay. So that's some basic syntax. This plus, I can tell you, I use this all the time for what I need to do in my work. Now, what if I actually had, like, let's say I wanted to match something like C++. How could I write that? Well, I can obviously write C, right? That'll capture that, but how do I write plus plus? I can't use the plus character because it's already reserved as a symbol in regular expressions. So to do that, I need to use a backslash before the plus, and that will escape the character and give me access to that character as part of my pattern, rather than as a decorator for my pattern. So I could also put 2 pluses in here, which captures that, but I could also say, like, let's say I wanted to capture C++, C++, and then just like a bunch of pluses. How would I do that? I want to capture C and as many pluses as you'll give me. So again, we can say 1 or more, right, with a non-escaped plus. Now let's say I only wanted to capture 2 or more. I can do that with some other quantifiers. Here, I have in curly braces, I have the ability to do quantified matches. So inside of this, I could say match only 2. And that matches here, not here, here again, and here again. Let me actually make this 3. All right, so you can see how that works. Now let's say I wanted to do 2 or more. I could say 2, comma, and then don't put anything after it. And that gives me everything except my C plus here. which is a crappy grade anyway. We don't want that. Now, let's say I wanted only like 2 to 4. If I put a limit on it, notice that it won't capture this extra plus here. I think that's C#. Isn't that the idea? Was that C# was C++, 2 pluses, and then 2 pluses underneath of it to make the pound sign? Yeah, that's what it is. That might be a myth, but I read that somewhere. Okay, let's see. So we've done some of these. What else do we need to do? So alternation. Let's say I wanted C or D. I can use the pipe to match C or D. Real handy there if I have options. Real important version. Also, if I want to have an optional match, where it's like, I'll do yes, and then with a question mark in front of the comma, that means that the preceding token is optional. So you can see the example here is color, but watch this. Let me add something to our patterns here. This is why I love the optional match. If I match HTTP S optional, I'll capture both, both URL schemes or URI schemes for HTTP and HTTPS. And then of course I can add the colon, but then for the // it's actually not gonna work if I use it in Vim. I need to escape those characters. So this is where we start talking about like the evil of a bunch of slashes in your regular expression, and it starts to get a little bit confusing. Now, we're well on our way to making a URL pattern match, right? Something that we're probably going to need to do at one point or another, especially if you have to extract data from something like a sim that doesn't have fields parsed, right? If I need to look for my URL history or even domain names, if I'm looking in DNS records and they're not parsed, that one hits close to home because I've definitely written this query. You have to write the pattern to match on a regular expression. So how do we match for full URLs here? Well, we know that they're going to start with the scheme, right? And then they're going to have the domain, and that goes the new top level domains make this a little bit more annoying. But as a starting point, we can say, okay, well, we know that the characters that are allowed in domains are like A to Z, capital A to Z, and dashes, or digits, so let's do 0 through 9, and also dashes. And you see that matched 1, and I know that there's going to be 1 or more of them. So that takes me through there. And then let's say I know that at some point we're going to need a dot. Now, dot is tricky because dot by itself actually means something else. A dot actually means everything. It's a wildcard in regular expressions. So that took some getting used to for me. I'm used to using the asterisk as a wildcard, but in regular expressions, a dot is actually a wildcard. Dot means match anything, one of anything, except for line breaks. And except for line breaks. So if we don't want that, we actually want the dot. Again, we're going to escape it with a backslash. Oh, all of that then a dot. There we go. And then, how do we deal with the top-level domain? Well, the problem with the top-level domain is that there's a bunch of them, right? So we can try to say, like, com or org, right? But that doesn't really work. Yeah, that doesn't really work either, because we can't really do capture groups that way. So how do I start writing, you know, a reasonable top-level domain? One kind of simple way would be with the dot, and then we could do AZ, the same. The top-level domains, I believe, don't have numbers in them, right? And we know that it would be, like the smallest ones are 2, right? So it would be 2 or more. That is pretty naive. I think there are better patterns for matching URLs, but this is a start. So you can see how we would build this to match URLs in a piece of text that we were working with. Let's try another one. Let's try an email address. You guys have seen this email address on the streams, so I don't really care about using it. But how do we match on those? Let's try one of those. So for an email address, we kind of know, well, let's kind of build from the center, which is, we know there's going to be an @ sign in there somewhere. And actually, we know that the domain is going to be very similar to what we just did. So it'll be something like AZ 0 through 9 and a dash, right? For one or more. And then we know we're going to have a dot. And the same thing again, right? AZ, for 2 or more. Right? Matches that. And then on the other side of it, we could do AZ. Actually, in this case, we might want to do just words. Right? Word characters. Now, again, this is a pretty naive email address pattern, and there are better ones you can look for, but to a first approximation, this will get you most of what you need. I'm curious now. Yeah, I want to see the list of all top-level domains. So there's nothing smaller than 2. They get really large, but there are no oh, dang, I don't know what these are. Oh wait, these are Punycode, which we haven't talked about, but these are for adding extended characters like Chinese characters into URLs. But they'll still, so there are some numbers that might match. But other than that, it's all A through Z lowercase or capital if somebody writes it that way. Cool. Actually, while I have that open, let me try something. I have a Chrome extension that I deeply love called Vimium, which gives me Vim key bindings inside my browser, one of which is search. I don't think you can, oh, you can't see it because it's at the bottom right. Let me turn my camera off real quick. I always forget how to do this. There we go. So down at the bottom right here, you can see I've got this kind of different search bar. Now let's see if I can do like 0 through 9. I don't think it'll take, yeah, it doesn't actually take regular expressions, unfortunately. I need to search a different way for that. Like, for example, taking this list into Vim. All right. What haven't we covered? Anchors. Pretty important. So if I want to look for things at the beginning of a line, at the end of the line, so example, I want exact line matches, I can use the caret and $sign to signify the beginning and end of a line. Really helpful if I just want things that are like the whole line. Also, this is something I'm going to show you in Vim. I'm going to take this jeffsum, this text, and put it in Vim. Yeah, paste anyway, please. Now, let's say that I wanted to get rid of... This color scheme is bumming me out. Ah! Never mind. I guess we're going to live with it. That was horrifying. Okay, so... Let's say I wanted to get rid of all the empty lines in this body of text, which I have to do all the time, right? If somebody gives you like an Excel spreadsheet and they have like empty cells in it, and I copy it over into Vim because I just want the text, how do I easily get rid of all the empty lines? This stuff seems like it's tedious, and it kind of is, but being able to do this stuff quickly makes you a much better analyst and makes you just faster at everything that you want to do. Right? You shouldn't have to while away your time doing a bunch of boring text processing. So using stuff like regular expressions makes you faster at that. So I have a bunch of these empty lines here. And let me add a bunch more in here, just to prove a point. Now let's say I wanted to get rid of every single empty line. Well, what I could do is I could use the global command in Vim, that's down at the bottom left there, the G, and then with a /, there's that syntax again, I could say, okay, I'm going to match on anything that has the beginning of a line, the end of the line, and there's nothing in it. And then what am I going to do with each one of those? For the global command in Vim, after I match my pattern, I give it the Vim command that I want to perform on everything that matches. In this case, I'm going to say D for delete. All my empty lines are gone, with just a little bit of regular expression. You know, similarly, if I wanted to get rid of every exclamation point, or yeah, let's do that. So just global, match on an exclamation point, delete that. Oops. D will delete the line is the problem, so every line that had the exclamation point. If I do X, I think it'll just get rid of the... Nope. I don't have X as an option to just delete the specific line. So instead of the global command, what I will do is the substitute command. Now, substitute is kind of interesting because if I do S, you'll kind of see what happens. If I do, if I look for exclamation points and replace it with like the interrobang, like that, and do it globally, it'll say pattern not found. And you might think, but there's definitely an exclamation point in here. Why is that happening? Vim uses its substitution a little bit strangely. What you have to do is give it the current buffer. I know this isn't supposed to be about Vim specifically, but in case you're using it, just know this. With Vim, if I want to perform these operations, I want to first use the % sign. Percent represents the current text buffer that you're working with in Vim. And what that does is it kind of pipes that buffer into the command that you're going to work with. So %s is substitute in the current buffer. So here, if I do an exclamation point and replace it with, let's say, the interrobang, and I do that globally, now all of the exclamation points have been replaced with interrobangs, but I had to give it that buffer in order to work with it. Okay. By the way, if anybody in the chat has questions either about stuff for regular expressions or what we're doing, clarifying questions, things that I'm moving too fast on, please don't hesitate to ask. I will answer any questions that I can, and if I can't, we'll find out the answer together. Let's see, capture groups. Do we want to do that now? I think we do. So capture groups are really valuable. What do? They allow us to group a pattern match and then kind of refer back to it later. So, for example, let's say in my text that I wanted to match something and then keep it, right? Without having to necessarily retype it. What I could do is I could use a %s, right? There's my substitution again. And then I'm going to do a pattern match. Now in Vim, we can't do a straight parentheses. Actually in Vim, it's flipped to if I do a search for a parentheses, if I look for parentheses, it'll actually try to find them. So I actually have to escape it here for my capture group. And if I want to substitute every yes with yes and an exclamation point, rather than typing yes again, what I can do is actually refer back to the capture group with / and then 1, because it's capture group 1, and then add an exclamation point. You see that it kept the yes, but it added the exclamation point here. So capture group's extremely powerful, especially if I want to hang on to something in a substitution. Really, really, really cool. Okay, we have a question. I was trying to regex some IP addresses. I want to find all IP addresses starting 192.168.1, but not 192.168.1.53 or 192.168.1.54. Is there a way to exclude whole strings? Well, that depends. Is your limiting factor? Let's make some. So basically, we're talking about the entire /24 subnet on 192.168.1, right? So let's check this out. Let's do touch ips.txt, and this is fun. This is gonna be a good exercise. I'm gonna use fish to do this just because I can. So for a in, watch that, seek 1254, we'll do 2. Echo 192.168.1 dot a ips.txt and how fun is that? Okay, so now we have a bunch of IPs. Okay, so where do you want the pattern to stop matching? Is it just the single digits? Or is there some other value that we're trying to match on? Because if I want to do single digits, I can definitely do that, right? So if I just want from 1 to 10, I could do the whole IP address. So Well, we can find the whole IP address. But it sounds like you're to see if there were any IPs on the subnet other than the two I knew about. Okay. I got you. So we could do something like we could do a search for 192 have to escape the dot. Let's actually, you know what? Let's let me, I don't know if I have my clipboard set up here correctly. But if I do, this will work. I don't, but that's fine. I will just open up the text file in like dumb notepad or something and just do a little copy pasta here. All right, let's throw that in here. So we only want to match on IP addresses that you don't know about. All right, so obviously we're going to do 192.168.1. Good so far. But then we want to do, you're saying, obviously we need to have like, let's say, tricky. So you don't want to match on 53 or 54, but you want to match on everything else. Let's say 0 through 9, 1 to 3. But now, here's the part I think that we might be able to work with, which is a negative look behind. No, because that'll match before the main expression. If it matches, the result is discarded. Let's try this. Let's try a negative look ahead. I think that might do it. Reference to non-existent group. 53. Negative look ahead. There we go. So that'll catch 53 or 4. So that's matching on everything that doesn't have 53 or 54. Yep, negative look aheads. These are, like, for me, the hardest part of regex to keep in my head, like how they work. But once you figure it out, like, man, they're powerful. All right. Let's do some regex challenges. You know, we've been doing some practice, but let's put our money where our mouth is here. There are 2 places that I found that have some pretty cool regex challenges that I think we can play with. The first is HackerRank, which, if you're not familiar with HackerRank, it's not specifically for, you know, cybersecurity folks. It's really about programming, but really good stuff in like functional programming, close, near and dear to my heart, but Linux shell stuff as well. So to your point about, you know, big files, there are many times where I have solved seemingly intractable problems with regex plus vim. And part of the power there is where I can do something like that global 192.168. Let's take that pattern actually. 192.168.1 and then we'll do the negative look ahead 53, 54. And just knock off everything that doesn't match that. Oh, what I forgot to do the escapes for the parentheses. I might have to escape extra stuff. Sometimes the Vim syntax is a little bit different. Oh, okay. So it actually, I don't think I need the... Is it reversed for the dots? Is that the issue? I can never keep that straight. Oh well, I will look that up at some point. But let's see if we can play with some regular expression challenges here. But yeah, HackerRank is mainly about programming, but there are some really cool skills in regex here that we can play with. There's also this link here, and I'll put that in the chat, that I found that is just the regular expressions game. So, write a regular expression for extracting text portions to follow patterns specified by examples. So, this is an example in which you have to extract a number like 1, 2, 3, 4, or /20 or 25. Okay. Can I play it or not? Is Brave messing me up? Let me turn Vimium off. Why is this disabled? That was weird. Okay, well, let's try it. So how do we match numbers? That would be /D as far as I'm concerned. Plus. Is this also disabled? Why is this happening? Alright, well, I guess the regex game is broken, so I guess we're not going to be playing with that one. Very odd. Alright, well, HackerRank it is. Try dark mode. Yes, please. Okay, so here in HackerRank, let's see what we need to do. We're going to use... regular expressions. You have a test string S. Your task is to match the string HackerRank. This is case sensitive. So this is actually a little bit of Python, which you may end up using. And let me get the Python docs up, because the RE library... Speaking of regular expressions, is a little bit different than just doing matches in Vim. Oh, those were the examples. Oh, I see. I'm experienced. Boo. Boo for the binary genders. Age. I'm 34. Okay, good call. Good call. Oh, regex crossword. That's a killer one. Yeah. Matches any character except line breaks. What? Now I have to take a survey? Why don't I just leave all of these off so that we can do everything? Okay. So we have to extract numbers 12, 47, 48. So that would be \D, and then we have to do... All right, cool. So task 1 has been completed. So that's level 1, right? What if I do level 2? Oh, here I have to do... So it doesn't need a plus because it's matching all of them independently. I could do... If I did like D1, then it still matches because it matches everything else. But if I did D2, I missed some things, right? Because I missed the individual. But yeah. That works too. Level 2. Here's MAC addresses. So this is fun. MAC addresses are hex. So for hexadecimal, we're going to need... it looks like they're done in lowercase, which is handy. So we're going to do digits 0 through 9. And lowercase a through z. 2. And then a colon. That's optional. And then that happens 6 times. A through F, good call. Yep. So let's break that down. Let me zoom that in just a little bit. So what are we doing here with this regular expression? The first thing we're doing is we're capturing this group because I want to use it. But here I'm saying, okay, characters in the digits 0 through 9 and A through F, good call, because hexadecimal ends at F. Not Z. But we know that there's going to be 2 of them, right? In these separations, 3-8, F8, B7, whatever they are. Now, here's the thing with the colon. I could have done this another way, but here's the thing with a colon. If I took off this question mark, it would match everything except... Oh, actually, it wouldn't match anything. If I take off the enumeration, it matches everything but that last section because there's no colon after that, right? Now this matches too much. So I need that colon in there to delineate the MAC address. So, but I know that the last bit is optional because one of the 6 times I don't have a colon after those numbers. So I put the question mark there, but then I say, okay, this pattern, I need to group it. Because then I want to say that whole thing occurs 6 times. And that gets me the MAC address match. All right. Now we're matching FTP URLs. Those actually should be escaped. And let's see. Can I just really go like word and dot plus and backslash? Yeah, I think that got it. So basically this is a less restrictive version of the pattern that we were doing for URL matching before, where we're doing so FTP : and then we're escaping the forward slashes. They were being kind to us and not requiring that we do that, but I'm doing it anyway because if I'm going to do this in Vim, I want to get comfortable just escaping my slashes and not freaking out when I see this, because this is hard to read when you start, but you know, you get used to it. All right, let's submit that. Okay. Whoa. Oh, God. This is going to be rough. What does everything here have in common? Okay, it begins with a $, which we absolutely have to escape. Okay, it doesn't necessarily have a backslash after it. It may have, so we'll do a backslash optional. And then words. Oops, backslash. And then all words. And we know that it ends with a $, right? So we're going to have to add some stuff to this group here. So it's words, it's underscores, and it's curly braces. Okay. Oh, man. Oh, by the way, this is a LaTeX. If you're not clear what's going on, this is a LaTeX math equation. Okay, so we need to match, inside this group, we also need to match a space and an equal sign. Crap. That didn't work. Let's do the backslash in there, because we need that as well. Yeah, just go ahead. Same page. And the plus symbol, I think. Problem is we're grabbing too much now. Potentially because of that single quote. So this didn't stop because of the space. There is a greedy and lazy. There we go. Makes the preceding quantifier lazy, causing it to match as few characters as possible. Although I'm not sure where I would put it. Not there. If I put it there, it throws that off. What's the issue here is the space is around the equal sign. If I Now, if that's... Now, are we overthinking this? I think we might be overthinking this. Everything we're dealing with is inside of dollar signs. No. Okay, guess that didn't work. Capture group around everything. Make the group lazy. No. Okay. This is where, like, at some point, maybe starting over is handy here. So let's see. Space in the capture group, too. Spaces in the capture group. Oh, snap. It's close. You said make it lazy. No. Oh, wait. Are we there? You know, you gotta make, No, it was close. The capture group helped us out. I think we got it. So, what was the thing? There was an ore in there for some reason, which was killing us. This ore. That was the issue. So, let's break this down. We're beginning... with a $sign. We're ending with a $sign. And then inside of it, we're allowed to have a backslash, maybe, first. Actually, do we even need this? No, we don't. So then we're going to say the group of, you know, all alphanumerics, the underscore, the curly braces, a backslash, a space, and equal sign, and a plus sign, as well as a single quote, can happen more than one time. And then we got another $sign on the other end of it. And that does the deal. Cool. Hey, IP addresses. Do we not need the capture group? Let's find out. No, you do not need the capture group. You are correct. All right, IP addresses. Boy, I've written this one enough times. I should have it. So this is going to be 0 through 9 with a dot. The dot, and make the dot optional. And then what we're going to do is we're going to capture this whole group. and say that that appears 4 times. Very similar to what we actually did before to try to exclude the other IP addresses. So again, what are we doing? We're saying, now this is a good pattern match for an IP address, but it's not a logic match for an IP address. Did it catch the ports? Oh, it did. Interesting. All right, we'll deal with that in a second. But I want to say that before we fix that, that this is not a logic match for IP addresses, meaning that I could have an insane IP address in here. I could have like a 500 or something in one of the octets, and this would still match because it's just checking for the right number of digits. It's not saying, you know, is this within 0 to 255? Oh, this caught ports. Why did it do that? Interesting. Oh, you know what? Okay, so let's do this. Let's say 3, and then yeah. So let's say we need the dots. We do that 3 times. And then we do comme ça. That does it. Yeah. Cool. So because we had those ports there, we had to be a little bit more explicit with the pattern than we could be before. All right, here's another one where we're doing URL matches. This is something that I'll do all the time in Recon. And as a matter of fact, you know, if I do like a curl for this, like if I pull down HTML or something like that, the first thing I'll do is I'll pipe it through like egrep or something like that to get specifically you know, web links or something like that. And as a matter of fact, when we do spidering, right, when we do things like Zap, when we're scanning a website, that's also what it's doing, right? It's parsing the document and looking for those sorts of attributes. So we know that we're going to start with href, easy enough, an equal sign and a quote sign. And then let's see if I can cheat this a little bit. Dot star, whoa. No, can't get away with that because I've got stuff that prepends it. They don't all end with slash, so unfortunately I can't be that lazy. All right. Well, we know that we're going to do W // dots equal sign. Looks like an ampersand in there. Semicolon. Oh yeah, maybe just not space. Let's try that. That's not quite how I want to express that. because I can't do a negation outside of a group, right? Sorry, not a group, but a character class. Yeah, I negated set. Not space. So what does that miss? That misses this for... Oh, because it uses a single quote. Great. Let's try... Yeah. No, there's good recommendations and it's good experimentation. Please don't. But I had a feeling that they weren't going to make it that easy for us. So let's see here. So, but it's a good call out actually that we are going to need that that capture group here because I can't, I have to stop that from happening. Yeah. So that doesn't work. So that doesn't work either. Digits and words plus. Unfortunately, because there's too much other stuff. Let's do D, W. What else do we have in here? Colons, semicolons. That's not working at all. Okay, so that works. Now, what about... Okay, I think I just have to complete the set here, and then we'll be good. So, what do I need? All words, all... Ooh! Words or digits. Are there any tools that let you paste in multiple strings and generate regex that matches them? Sounds like a nightmare programming project. My god. That sounds really tricky. I don't know of anything that does, but... Ugh. Yeah, that's like going the wrong way. I will say, one of the hardest bits of regular expression that I've done in real life, I can actually show people now. This is work that just got published. See if I can find the thing. Yeah, this was a project I did as an independent contractor. Really cool thing. So the Nelson Atkins Museum of Art in Kansas City, Missouri, has a killer new online catalog of their French paintings. I know this is totally like out of left field and not the usual kind of thing that we talk about, but museums are kind of a big part of my life, so it was exciting to get to work on this project as an independent contractor. And what we did was we took an open source tool that was built to kind of publish digital humanities, and we expanded it a little bit with some pretty cool extra features like there's the watermill. Wait, this is dumb. I should actually use the feature that I'm talking about. So the search feature was actually kind of tricky because this is a static site. And so how do you write a searcher that actually does the thing that we want it to? In order to search, the problem is that there's a bunch of text in this document. And it's like, how do you actually show the part that you want to match? So what we had to do is actually write a regular expression parser that basically took the pattern that was matching in the search and then looked ahead to the end of either the sentence or the paragraph. It looked to the end of the paragraph or the line break, and then looked behind a certain number of characters and gave you kind of that excerpt. So the idea was to try to pull a snippet for the search result that was sane. And doing that with regular expressions was a nightmare, but we were able to get it to work for anything that actually does have text. Oh. They might have not linked up the contents yet. This was my pride and joy, though. This right here. There were two things we did. The first was create a dynamic resizer for the image viewer. That was super fun. And then also, because there are in many cases multiple images in a set, we created a dual viewer for comparison view, and you could set, whichever one you wanted to be using. All right. Anyway, you can check that out at nelsonatkins.org/FPC if you want to see some really cool French paintings and support a great museum. All right, back to regular expressions. Okay, so we've got words, digits. We know that we need forward slashes. We know that we need dots. We're starting to capture some. And we know that we've got a question mark in there. And an ampersand. And an equal sign. There we go. Starting to get there. It's a pound sign. Semicolon. Question mark. We already got the question mark. Colon for all the HTTPs. Do we not have a dot? We have a dot. Why isn't this one catching? Oh, wait. Ats and percents. Okay. Do we have to backslash both of those? Oh, and pluses. Yeah. This one has a capital. But that should still catch. Oh, the parentheses. It's the parentheses. Parentheses and single quotes. Well, that was obnoxious. Okay. that's enough of the game, I think. Let's do something real. I wanted to do a password policy, because this is actually a cybersecurity thing that we care about. The password policies, you know, hot topic as always. People can have different, reasonable people can disagree about a good password policy. I personally don't like thinking about the term, this is just me, this is not the opinion of my employer or anything like that, but as goes for everything on the stream, of course, but specifically the comments here are not comments about, you know, my employer's password policies, but I personally prefer to talk about passwords as passphrases. I want to socialize the idea that creating, it's like correct horse battery staple, right? And just in case anybody hasn't seen that, the basic idea is that passphrases get around the problem of bad passwords, or like passwords that meet policy but are actually terrible for humans, where, like, plus this is actually super guessable, it turns out, right? These substitutions aren't hard for a brute forcer to do, so they're not actually that secure even though they meet policy. Whereas if you create a phrase like this, okay, it's all the same class of characters, but the length is doing the complexity for you, and it's actually much easier for a human being to remember. Now, should you be using a password manager? Definitely. Should you be using different passwords for every account? Yes, of course. But it doesn't negate the fact that sometimes you gotta remember a password, you know? And if you make it easy by policy to remember that, you know, easy enough to do. My password is now correct horse battery stable 4 since I saw that a few months ago. Good work. Yeah. There, man, Tara, I want to say Wheeler? Is that right? Yeah. Deviant Olaf's, well, I should actually say that Deviant is, her husband. She's a badass, is what she is. But she put together, see if it's search for nerd list. Yeah, there it is. So there's this extra password list called the nerd list that she put together of like dorky stuff that people use in passwords. And these are things, it's actually a pretty solid password list. It's stuff that people will use if they're nerds. So like Cyberpunk 77, all the stuff that you would find in like, oh yeah, this is from Cthulhu, #1 Engage. There's a bunch of stuff that is like from popular culture that's in here, right? And that's, and all of these, by the way, have made it on here. This is interesting. All of the stuff on here has made it on by a review process, if I remember the talk that Tara gave about this correctly, that have been validated to work someplace. Right? So, pretty cool one to follow. Let me actually start this right now. Yeah, the nerd list. Anyway, so let's build, first of all, a password policy checker, right? And then let's test it against a bunch of passwords. So in terms of bunch of passwords, I have one, and I'm pulling my bunch of passwords from Daniel Missler's SecLists, which is another kind of must-have database of stuff. SecLists is just awesome. It's a gigantic repository, but if you pull it down, by the way, if you pull this down on a tool that has good antivirus on it, or EDR, it will yell at you. I'm definitely one of the most annoying people in my organization because of how many EDR alerts I trigger based on tools that I download. But what you can get is like these really good lists of passwords. And like RockU is in here and all the other, pretty common ones. But Today, we're going to use the the dark web top 10,000. And I wanted to be a kind of beefy list specifically to see like how we would do this appropriately. Now, what we're going to do is we're going to write a password policy and we're going to implement a checker to see which of the things in our list actually match the policy. Some of them are going to, right? But they're still terrible passwords. And to prove the point that a policy isn't everything. All right. So let's start. I'm going to do this in Python, I think is the easiest way to do it. So we're going to start with creating our file, our Python script. So we're going to do yuch, good, touch policy check .py. And what we're going to, the structure of this is we're going to write some different policies and we're going to run multiple checks against those policies. So let's do it. So we're going to import the RE library because our regular expression library is how we're going to do these matches. And you can see that it's the same kind of syntax that we were doing before. I'll make sure not to refer to anything that is below my head on here. But very similar to what we've done before. Right? All the look-aheads are in there. The trick is what we actually get back from RE. So we define the pattern, right, with a string, but then we use the RE methods to actually make it happen. And there's match, there's search, and depending on what you're doing, it'll return different things. So re.search, scan through a string looking for the first location where the regular expression produces a match and return a corresponding match object. This is where it's a little bit different than just like using it in Vim or something. Returns none if no position in the string matches the pattern. Note that this is different from finding a zero length match. Okay, and then match if 0 or more characters at the beginning of the string match the regular pattern, returning a corresponding match object. Return none if the string does not match. So this is probably, actually full match is what we want to do because we're testing the specific policy or the specific string, right? So full match, if the whole string matches the regular expression pattern, return a corresponding match object. Return none if the string does not match. So full match is going to be our friend here. That's what we're going to use to test the policy. Now let's write some policies. The first thing we're going to do is actually write the policy function, and specifically we're going to do it in such a way that it is policy agnostic. And I'm also going to use the cool Python type hinting that you can do now because I can. I love this. So this is Python, but I can do this. These are type hints. These were introduced in Python 3.6, where I can say, okay, pattern is going to be a string, and then it returns a bool. This doesn't do anything in compiling. Right? If I actually wanted to do like real typing in Python, there is a typing module. Right, so you can see here that type hinting is supported. Actually, I should have put a colon here. Yeah. So type hinting is supported even without the typing library. But notice that what it says, the Python runtime does not enforce functions and variable type annotations. But I can actually import these types and kind of use them as some guarantee if I want that kind of typing. But I don't think I need it here. I'm just for clarity. So we're going to say check policy, pattern, and then test, also string. And then we're going to say re.fullmatch. So the pattern is going to be our pattern coming in and test, right? Pattern test. Actually, I can do this as a one-liner if I wanted to. I could say return. We'll do it this way. Return true. Otherwise, return false. And because it's a return, I don't need the else statement. I can just say return right there. Now, we can define some policies. And so I'm going to do these globally. Let's do the 8 or more. That's going to be our policy to say that it is longer than 8 characters. That is going to be a the pattern is going to be anything for 8 or more. And that's kind of it as far as that policy goes. Let's say alphanumeric. Now we're going to say that policy is A to Z, 0 through 9. Right? So now these are not exclusive. So what we could do, right, if we're doing a full policy, right, but I'm breaking these down for a reason, because we can run them independently. Now, time for a little fun Python development trick. I am going to split my window here. And fire up IPython, interactive Python. So down here, I basically have a REPL for my development, and I have the code up at the top, but I can import it down here. Trying to remember, there's one thing I need to do to make this work really well. And I always forget. Yeah, there we go. So what I'm doing here is I'm doing a load extension, auto reload, and then set auto reload to 2. What this does is anytime I save my code, anytime this changes, the new code will be automatically loaded back into my IPython session. So say import policy check. Or actually, I can say from policy check, import star. That's what I want. So now if I ask for policies, I have them, right? I have them available to me in my interactive Python shell. Pretty cool, right? So what I can do from here is I can run check policy. And I can give it the pattern, right? Whatever pattern I want. I say policies 8 or more. And then I can say, let's test it against something, right? Pattern matches, right? Really cool. Now let's give it a false, right? Let's give it something too small. Meets that policy. Now let's try the alphanumeric. This one is broken, actually. This one will match even though it doesn't actually pass. Right? Because it's not. It's just, it needs to have letters and numbers. So how do we say it needs letters and numbers? I don't know. How do you say that it needs letters and numbers? It must have I'm wondering if nope. What do I want? Lookarounds, right? Matches a group before the main expression, but I do want it there. I need to have letters and numbers, not letters or numbers. Two positive look-aheads, one for letters, one for numbers. The thing is that it doesn't include it in the result. So if I do two positive look-aheads, neither one will be included in the pattern that matches. But maybe. Let's actually try it. We're right here. So two positive look-aheads. Oops, those are negative look-aheads. So the positive look-ahead doesn't do the job. problem is that matches both alpha and numeric, but it doesn't match. It doesn't require both, right? I mean, my first instinct would be to write two policies, right? One for must have numbers. Right? So if we do something like, and that's kind of the point I was trying to make before about making the multiple. So the actual policy would be like, whoa. The policy would be like as numbers like that, right? And then write another policy that says special cars, and then we give it our special cars, right? Where it would be like, we're gonna have to escape some of these, but we could allow those, right? If we wanted to. And my thinking was we build a policy checker for each each small piece of the policy, and then you tell which one it passes and which one it fails. And that is also kind of like how the password validations do it too, right? Because it tells you like, oh, you must have special characters. Everything else is good, but this doesn't work. Let's do underscores as well. Okay, let's write that. And then let's try check policy special cars. This should fail. Okay, if I give an exclamation point, hey, that should pass. Yeah, I've written a bunch of regular expression rules in pandas for the same thing. Whew. All right, let's try that. So if I do policies, special cars, oh, it's because the regex is wrong. Oh wait, no, it's not. It's just printing funny because it's in Python. If I had said print that, it would have come out correctly, I think. Yeah. Okay. Let's check out the RE documentation just in case I'm missing something. Causes the resulting match one or more. That's all good. Yeah, so all these would need to be escaped. That's correct. Special characters lose their meaning inside sets. For example, match any of the literal characters. Oh, that's really interesting. Special characters lose their meaning inside sets, which means that we don't need to be escaping these at all. I can also use re.escape. Yeah. Good to know. All right, let's re-import this thing. Still not working out for me. Let's try that. Let's see what happens if I re.escape this. See, I think the problem is that it's escaping the whole, every character, you know what I mean? Yeah, because it's not honoring the character grouping, the character class. Well, that's all right. Let's just write just the like basic one, right? Keep it simple. Okay, well that obviously should have worked. Let's try this. Oh, I wonder if it is like that. There it is. That's the problem. It was just matching just that, but it's not a full match. The whole thing has to match the pattern, right? So in order for this to work, let me undo this. In order for this to work, I believe what we need is to say, okay, anything can precede it. re.search would work, but I don't want to have to rewrite the thing. You know what I mean? I want full match to do the job for each policy. So one or more of this character class and anything before and anything after. Yeah, there we go. So that's a good reminder. So when we're doing these policies, you have to be matching against the full string because we're doing full match. All right, so that makes sense. So we've got inner has numbers, special characters. So we've got 3 policies that are pretty common, right? They're not the best, but they're pretty common. So what can we do from this? Now I want to make this a command line useful tool, right? So I'm going to import 2 things. I'm going to import sys, and I'm going to import CSV. So here's what we're going to do. With sys and CSV, we're going to say, I'm going to write a main function. And then just to prove that it works, I'm going to say like print it works. Now, do I have that yet? No, I still have to re-import it. I guess the auto reload didn't actually take. So the main function works here. And then if I were to, let me full screen my terminal for a second. If I were to, I should have seen that coming. There we go. Over here, if I were to go over into here and I do Python 3 policy check.py, oh, I have to put in the special Python run the thing if name, nope, equals main. Right? Yeah. So that tells it to just fire off. And that's just a nice wrapper for the main function if you're used to writing in languages that have main functions. Okay. So, what we're going to do in the main function is we're going to say, we're going to say try pw file equals sys.argv2. So we're going to pull in the file that we want to check from the command line. And actually, I just want the string for now, and you'll see why. And then if that doesn't work, we're going to say except. Now I should be more explicit with my except, but for now, it is what it is. Oh, I'm being stupid. This needs to be in the main function, not in this. There we go. So if we accept that, and we don't, if something goes wrong, we're going to just print okay, and we'll do sys.exit 1 to give it a proper exit code. So I guess I can just stay in the terminal for now. So let me split this over so we can run it over here. This says couldn't open password file, right? If I give it the, let me change the code so it actually prints it otherwise. Just to get started. And now I'm going to give it passwordlist.txt. Oh no! It's argv1, not 2. I was 1 off. There we go. Okay, so we have the passwordlist.txt open, And so what we're going to do with it is we're going to actually run the thing. So we're going to say with open pw file as f passwords equals f dot. Now here's the problem with read lines. And I'll just show it to you really quickly. For key in passwords, and we're just going to do the first 10 of them just so you can see it. We're going to do print p. And actually, I can put this... I can put this outside of my loop, or my with open, because I have the passwords saved already. What I like about the with open, in case you're not familiar with the syntax in Python, is that it saves me, this with saves me from having to manually open and manually close the file. So it's cleaning up the memory for me and closing the file pointer without me having to do it manually. Just a nice little memory saver. Now, here's what's going to happen. What we would expect to see, right, if we're just catting out the password list, is just line by line by line passwords, right? But what's going to happen, unless I miss my guess, is we're going to get line breaks between each one. Did I not write this? Yeah. There we go. So yeah, you see how I'm getting line breaks between each one? The problem is that the line in the text file has a line break on it. And I need to get rid of that thing. So the easiest way that I've found to do it, I mean, obviously if I do p.trim, that'll do it. But I don't want to have to do that every time, right? Why is this happening to me? Oh, there's some error in here. Oh, it's not trim, it's strip. And as a matter of fact, this block of code shouldn't even be in here. It should be after. Right? Because otherwise I was going to catch that error some other way. There we go. So now you can see that I'm getting the passwords without that. Now, the problem is that I don't know what else I'm gonna do with these passwords, and I don't want to have to like always remember to do strip for each one of them. So instead, I'm gonna do that here, really quickly, with this list map, and then. Well, let's take it piece by piece. The first thing I'm going to do is map something onto it. Now, map takes two arguments, a collection, a sequence, which readlines is going to be, and then the lambda function that we're going to apply to the thing. So in this case, the lambda function is going to be like lambda key, and then we're going to return p.strip. Now, that is all we need to, right out of the gate, take care of those line breaks. Here's the other trick though. This map object isn't as useful to me as the actual list, so I'm going to cast it into a list with this extra conversion right here. Now, I have a list of my passwords that doesn't, each one of them without the line break on it, so I don't have to worry about it moving forward. Just a nice little, safety tip that I found working with a bunch of text files. Still works, right? But I don't have that need to always do strip. I do it once, set it and forget it. Now, we need to build the policy object, right? The match object for each one of these. So what we're going to do is, for each password, we're not going to print the thing. We're going to check the policies. And we have to build the policy results. So we're going to create an empty list. And then we're going to say for I in policies results.append check policy, and the pattern is going to be policies brackets I, because when we loop through a dictionary in Python, it gives us the keys when we loop through it. So I'm using the key to access the actual pattern at that location in check policy. And then after that, I'm using the key password as my test. And then I'm just appending that to my results. Now I need to save this whole thing somewhere. I'm going to call it result rows for reasons which will become clear in just a moment. That also is going to be a list. And what I'm trying to do here is I'm trying to build a CSV, right? A comma separated value file so that I can easily read. Now, I don't have my headers yet, but you'll see how I get them. But the easiest way to do this here is I'm going to start the comma separated value file I'm imagining kind of looks like this. It's going to be like the password and then true, true, false for whatever policies that I build, right? So I'm going to start the row or result, right? Start the row with actually the password inside of it, because that's the first thing in the row. Then, as I get my results from my policy checker, I will append those results to the row. Okay? So we're going to append the policy checker. Looks good. And then, at the end of the password, at the end of the policy loop, right, we're going to result rows dot append result. Okay. So we're going through all the policies and we're checking each one. Now we have to write the thing. Now so far we haven't asked for our output file. Right now we could print it to standard out if we wanted to, and I tend to like doing that because then I can like pipe it to whatever I want. But if we wanted to, we could also ask for a second command line argument for the output file, right? So here we could say something like try CSV file equals sys.argv2. And then before we do anything else, right, we could say if there's a problem with that, we can accept it and print, couldn't write the CSV file and sys.exit 1, right? And then from there, we go to work. Actually, we should try this one we will put all inside the try because it's all one operation with the file. With open CSV file, and it's going to be a write operation. We're in write mode as F. We're going to do... Yeah, I will move this up, actually. Except that... Yeah, you're right. Yeah. So we check to confirm that. Now, whoa, why is that indented funny? Weird. Okay. All right, fair enough. So now, this would still be, honestly, in a try, with open. This error couldn't write to CSV file. This is no CSV file provided. Now with open CSV file in write mode, that's F. What we're going to do is CSV dot writer. And we give it the file F. And what we can do then with the writer is, oh my god, writer dot. So we can do write row and write rows. And what's cool about that is with write row, I can give it the policies, right? So kind of, I'm going to build the header row that way, and then we'll write that row. So let's see how that goes. So header row equals we'll call it password, comma, because it's a comma separated value file, right? Let me just check the CSV documentation. I always forget if the default writer expects a string or a list. I think it expects a list. Writer. Write the row parameter to the file according to the current dialect. A row must be an iterable of strings, so it does expect a list. So we're not going to do this manually. We can do like so. Password. Plus list policies dot keys. And what that does is gives us that nice header row. And we'll say writer dot write row header row. Yeah, write header. Write a row with the field names as specified in the constructor. The files, writer files object. So you can do that at any point, I think is the trick there. And also, it's part of dict writer, which is really, really cool. So the idea with the dict writer is that you give it like your list of dictionaries, and it'll extract the field names. So actually, if you're doing with this with, well, pandas does this for you, but if you don't want to deal with pandas, but you're dealing with a lot of like JSON data or something like that, it's really awesome because you can, well, sort of, I don't, is that right? Header would be keys, rows would be values. If it works like pandas does, if I recall correctly, what actually happens is that it extracts the keys from the rows and looks for differences. So like if I have one value, if I have one dict that has like a weird key, it'll make a new column for it. Just like if I give pandas a list of dictionaries, right, and I make a data frame from it, it'll make a new column if one of them has a weird key. Okay, so we're going to write the header row, and let me finish this except here. Right. Couldn't write the CSV file. And then we just do a writer.write rows. And you can see that, oh God, the typing, the autocompleter, the IntelliSense here is so nice. So it tells me that it takes a list of lists, which is exactly what we've built here in our result rows, right? Because we built this list and we put each of those tiny lists inside the big one. So that's exactly what we have ready for us in the result rows. So what we should have then is we will get a CSV of policy results for our passwords. And all right, looks like I didn't do anything dumb with my syntax checking. Let's give it a try and see what happens. And we'll call it result.csv. Name results is not defined. Good job. On line 35. Now, why? Oh, because it's result. There we go. That seems about right. 262K for my results.csv. Let's take a look at it. Okay, so... Oh, I was like, what's going on with some of these empty rows? They're not empty, it's just that LibreOffice turned them all into numbers. But yo, look at this. Totally worked. I have now policy results for each of these passwords in my 10,000 password list that I used. And it took no time whatsoever for Python to power through that. That was really fast. You can do this in any language, right? We did it in Python because, you know, Python's everywhere. You could do it in F#, which is, you know, my new thing. But really, really easy and a great way of doing like a quick review, a quick audit if you have a list of passwords that are you know, suspect. Because, you know, it's funny, you say sometimes in organizations you have policies that are set, but sometimes things can get grandfathered in and you just don't know. And so one thing that's actually part of our SOP is like, if we get credential dumps from one of our like reputation tracking services or something, yeah, we'll check it against our policy to see if it matches, but that's not always, you know, easy to do. So to see if it could even be a valid password for our environment before we go through the trouble of validating that it exists. So you could do something like this to check any password dumps against your policy to see if they even possibly could be real. But yeah, so that was our kind of quick introduction into regular expressions. We did some fun with regex today. And if you want to learn more, I'm trying to open the right thing there. So if you want to do more, you can check out the regex game that we put in chat, and also regexer.com for practice, and hackerrank.com also has some great challenges, especially if you want to learn how to do regular expression in Python. So that's going to do it for today. And of course, before we get out of here, I'm going to make a quick plug for our friends over at Human IT. They are a nonprofit that is providing low-cost internet connections and computing devices to families in need. If you have some spare cash that you could donate, that would be great. If you have lightly used computing devices, they'll take them and give them to folks who really need them to go to school, to get new jobs, whatever it is. So you can check them out at humanit.org. I will be back on Tuesday with Attack on Tuesday, where we do some offensive stuff in the cybersecurity realm. And then Wednesday, where we're continuing our learning of F#. So thanks everybody for hanging out. Happy hacking, and we'll see you next time.